So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, this week, we're going to be talking about solar and battery system reliability. Now, these systems are long-term assets, and it's not something you want to have going for 5 years. You want it going for 25 or 30 years. The dilemma is that the technologies that we're installing, whether solar panels or batteries, that technologies come and go, and products come and go, and even companies come and go. And every few years, I assess the most popular solar panel manufacturers. I kind of look back and see, how did the top 10 do? And of the top 10 companies in 2001, when I started doing installations, 0 are still selling panels in the U.S. Now, a couple of them, Kyocera and Sharp, are still meeting their warranty obligations, and those panels are good, but pretty much everybody else is kind of gone. And you see the same drop-off when I look at the big companies from 2010. So how can a customer, a homeowner, a commercial customer, a utility, or a financing company assess the long-term reliability of solar equipment? Because without good reliability data, financial benefits of systems are uncertain. And so the best way to do this is to scientifically assess and gather the reliability data. And the analysis can't be done by the manufacturers. It has to be done objectively and independently. Now, PV Evolution Labs is the leading independent lab for equipment testing. They assess the bankability of PV modules, of inverters, of storage, and other balance of system equipment. And my guest on today's show is Genya Maedbray. He's the CEO and co-founder of PV Evolution Labs. And, I'm thinking back, the last time I saw Genya was on the roof of his house when we were repowering his solar array. It's a long story. We'll put that aside. So welcome to the show, Genya.
Thanks, Barry. It's good to see you again on ground level this time.
Yeah, it's good. It's good. Well, we're not up to the Zoom level yet, but yeah, everybody's got to be independent. I'll give a little bit of a brief background about PV Evolution Labs. But why don't you tell our listeners a little bit more about the company and what you guys do?
Sounds good. Yeah, thanks for having me on. And the installation that you helped me out with on my house is going great. So I'd like to thank Cinnamon Solar and you for that. So PV Evolution Labs started back in 2010, a decade ago now, and with the goal of really providing a higher degree of technical qualification for the large buyers and investors in the solar industry. So prior to PV Evolution Labs, I worked at SunPower as a reliability engineer. And at SunPower acquired a developer EPC called PowerLight that was buying modules from everybody out there, standard suppliers at the time, Qcells and Suntech and Yingli. And when SunPower acquired PowerLight, I was tasked with developing a program to qualify our solar panel suppliers. And so I built out a lab in the office and started doing some reliability testing on these modules. And I expected to see that more or less a module is a module is a module, and maybe there are some slight differences. But what I was surprised to actually discover was that some modules really performed poorly, just really degraded a lot in the reliability tests. Some did okay, and some did very well. So the spectrum of performance was broad, and PowerLight and SunPower became a much smarter buyer of solar panels because of this process. And back in 2008, 2009, I was thinking, as the industry was taking off, that anybody that's making a long-term bet on a module performing should be doing this type of work. So that's the banks, the large developers, the investors. And so I left SunPower and started PV Evolution Labs to do a similar function, doing reliability testing on panels for the buy side of the market, for the folks that are taking a long-term bet on modules performance, and have slowly been ramping it up since then.
That's great. Who are your customers more specifically?
So direct customers of ours are the panel manufacturers. So we have a bit of a complicated customer structure. So we work for the panel manufacturers. They hire us to do reliability testing, to participate in what we call the product qualification program. And then we have a network of what we call downstream partners who are the largest banks and developers in the U.S. and globally. Currently, we have about 400 different companies as downstream partners. They represent probably 30 to 40 gigawatts per year of either installs or financing. And many of these large buyers require participation in the PVEL QP, or the PV Evolution Labs product qualification program. And we perform the reliability testing, bundle up the results, and present results to the large buyers. And they use that to qualify different modules. It's been a pretty effective process. The buyers all get the data for free, so it's pretty easy for them to require it and get the data. And the manufacturers participate as a way to get in front of the largest buyers in the market. So we're trying to help everybody, help the manufacturers make more sales, help the buyers do their homework before placing a long-term bet, and help the whole industry avoid any black eyes so we can continue growing at crazy rates.
Yeah, you're definitely helping the industry, and the service is just so useful. Just in my experience over the past 20 years or so, I've seen the same quality differences, and really only got bitten once from a supplier who, it's just the quality wasn't there. And we did some testing, and we actually found that there was an issue, and, they did their best to resolve it. But my approach right now is just sticking with the biggest companies. And we'll talk about that in a second. Now, Tell me a little bit about bankability. I mean, that's a term that people in the industry throw around, that financing companies and customers sometimes ask about. But what is bankability, and is there a good bankability list that somebody could take a look at?
Sure. Bankability at the end of the day is the willingness of a financial institution to finance a project at a competitive rate without taking some kind of haircut financially. So it's a function of the risk that the bank or the investors see in the product or the project. And that is a function of a lot of things. So it's not just technical, although the technical component is one part of it. It could be purely financial. So if a bank thinks a manufacturer is almost insolvent, they may deem them not bankable regardless of the quality of their equipment that they produce. We can help on the technical side. Obviously, we can't help on the financial side. So when a bank or an investor goes to make a long-term bet on a solar power plant, all of the capital expenditure is basically upfront. Solar, as everyone knows, has no fuel cost, has very minimal operating costs, and really all of the investment is in the upfront CapEx. And so the longer that initial investment lasts, the more kilowatt hours it generates over its lifetime, the less it degrades year over year, the more financially successful, economically successful the investment is. And so performing this reliability testing up front to develop your approved vendor list, which has now become a fairly standard process, kind of defines bankability. So there are a few different tools there. Bloomberg New Energy Finance for a long time has had this tier 1 list, which a lot of folks look at. That the criteria to be on the tier 1 list is purely a financing history. So if a module has been financed by an institutional bank, X number of institutional banks over the past Y years, then you get on the list. It doesn't say anything about the quality of the equipment. Our product qualification program, as I mentioned, it's free for the downstream participants to gain visibility into the test results. Sometimes it's a bit more information than folks are looking for. By every year, we release what we call the PV Module Reliability Scorecard. That's just a free download from our website. So the objective there is anybody can go access it without any NDAs or anything, and manufacturers that perform well are named by name. And so from a reliability perspective, I think the scorecard is a pretty good, probably the best tool out there to evaluate which manufacturers have gone through reliability testing and performed well. It's not perfect. It doesn't have 100% coverage. It doesn't cover, bankruptcy risk, but it's probably the best tool out there today.
All right. That's the useful metric. So how long do solar panels last? I mean, companies have standardized on a 25-year warranty. Where did that 25 years come from, and how long do they really last?
Yeah, that's a little bit of the million-dollar question is, what is the useful life of a solar panel? So 25 years came from, actually in 1997, Siemens Solar announced their extension of the module warranty from 10 years to 25 years. Before 1997, 10 years was the standard solar panel warranty. And, looking even further back in time, the way solar panel reliability started initially, the scientific research was the Jet Propulsion Laboratory, JPL, did what they called the block buy program. So they bought a bunch of modules, did a bunch of reliability testing, tweaked the tests, developed new tests, put a bunch of panels outdoors and tried to see how they correlated. They actually started this way back in the mid 70s and went out to the early 80s until what I hear is Reagan killed their budget. So no surprises there. And the current certification standards, UL and IEC, which were released in the mid 80s for the very first ones, are basically just where JPL left off. So in the early 80s, JPL had developed the testing to a certain point, and that became the UL and the IEC certifications in the mid 80s. And those are pretty unchanged today. Initially, when JPL started their work, the solar panel lifetime was something like 1 year. Based on their work, they increased it to about 10 years. So they did reliability testing. They fed back to the manufacturers. They changed their designs. And then, as I mentioned, in 97, that went from 10 to 25. And today, the industry has evolved a lot in the last 20 years. And, what used to be probably a tens of $1 million industry is now a hundreds of $1 billion industry. And some of the large manufacturers today are producing 50, 60, 70,000 panels per day, 365 days per year. So the volumes today are pretty astronomical, and the money put into the development of the product is quite impressive as well. And so the materials have evolved, the designs have evolved. 25 years is kind of the baseline expectation for the warranty. More recently, I would say in the past just 6 months, manufacturers have started pushing 30-year warranties. So 30-year warranties are starting to become more and more, I wouldn't say they're standard yet, but they're becoming common. And utility scale developers actually use a expected service life of 35 years, and some are even pushing 40 years. So who knows how long a solar panel lasts? There will be some replacements with these very long 35-year useful life assumptions where maybe in the last decade you assume a higher replacement rate, a higher failure rate. I think if solar panels are built well, without cutting any corners on the quality control in the manufacturing facility or cutting any corners on the bill of materials, I think there's no reason a panel can't last longer than 25 years.
Yeah. I mean,
30 years or 35 years.
Yeah, I mean, I've seen some really old small solar panels from Arco and Siemens from the 90s, and they're still, they're still working really, really well. Yeah, I think.
Yeah, exactly.
Yeah. So there's the warranty is 25 years. It almost, to me, seems it's kind of arbitrary. And then most of the incentive organizations require a 25-year warranty. So if you don't have 25 years, then you basically can't qualify for the incentive. So, but that's pretty darn good. I don't know anything else you can buy that's got a 25-year warranty. But then the next thing is, what can go wrong with solar panels, and how can customers tell? How can they determine if it's functioning properly?
Yeah. The technology of a solar panel is not so complex. They're made with silicon is the base material, glass, metal, and polymers. And that's basically it. They're a whole bunch of diodes basically wired up. The technology risk is minimal. The risk is really in quality control and materials. So what does a solar panel have to do for multiple decades? All of those materials have to stay adhered together. So if it starts coming unglued or the junction box falls off, that's considered a failure. That could be a safety risk because moisture can get in and you have high voltage conductors inside exposed to the environment. The internal circuitry has to stay continuous and operate with sufficiently low resistance. That means the wires connecting the solar cells have to basically stay attached. Those solder bonds have to maintain integrity. It has to maintain optical transparency, so the materials between the solar cell and the sun need to stay transparent. In the early days, we used to dope the glass, add a impurity into the glass called cerium, and then what we found was that it turns yellow when you put it outside after a couple of years. So the optical transparency goes down. Some of the early encapsulants also got really brown or yellow after being exposed to UV for a couple of years. So those were all swapped out. There's been a lot of development in the chemistry there. And of course, the solar panel has to perform, has to maintain its output. There's some degradation expected, but it has to be incremental and as low as possible. And so if a solar panel can maintain these properties for multiple decades, then we say, it works. It's not, there's nothing wrong with it. So what can go wrong with it is basically these things fail. The junction box falls off. The solder bonds that interconnect the solar cells can come apart. That's actually one of the more common issues in manufacturing quality control failures is they don't build those solder joints very well and they just come apart over time.
So how can customers tell? Do they have to go up and see if there's a junction box hanging down? Or, is there any other way for them to analyze the performance of an individual solar module?
Yeah, unfortunately, this gets back to why the warranties are a bit more of a marketing document than a technical document, is it's pretty hard to tell. So most manufacturers warrant that the performance will degrade at 0.7% per year or less. The reality is you can't measure that. That's a very tiny number. Unless a solar panel has degraded 30% or something like that.
Okay, so we talked about solar panels, but batteries are really what people are interested in buying now. And, it's a whole different world. It's like solar panels were 30 years ago. And everybody knows that batteries don't last as long as solar panels. So what kind of testing and evaluations can you do on batteries?
The product qualification program that I mentioned earlier that we developed initially for solar panels, we also have for batteries. So we run a PQP for energy storage systems, and an energy storage system is really the battery itself, the rack or the pack, which can have some differences and some electronics on it as well, and some controls on it as well, and then the system, which has a lot of controls and electronics on it. And we do extensive testing on all three of those components. And if a solar panel has fairly minimal technology risk, I would say batteries are different. Batteries have a lot of secret sauce in their chemistry. There are a lot of battery manufacturers emerging right now. It's, as you said, early days in the industry, and it's extremely dynamic. I will also say that stationary storage or energy storage in a house or in a power plant is a tiny fraction of what the battery industry is driving towards. Electric vehicles and electric buses is really what these battery manufacturers are pursuing. And the use case is different, and the use environment is different, and how you operate, how you optimize the chemistry of a battery is different for stationary storage versus an electric vehicle. So it's early days, but batteries definitely degrade. And the warranties on batteries exist, but they're also evolving. And it's, I think, far from being standardized at this point.
Yeah. I see a lot of battery systems, pretty much all the ones we're putting in, the manufacturers have a 10-year warranty. How can we tell? How can a customer tell, or even a contractor, how can they tell if these warranties are realistic? And what do they do if they're not?
Right. Initially, qualifying the product is kind of the best thing one can do right now, is doing the reliability testing on the battery cells and on the packs and on the systems. What we see from the reliability testing is that cells that are the same chemistry can have pretty different performance, and sometimes the performance is fine at a certain use condition and not fine at another use condition. So, for example, C rate, or the speed with which you cycle the battery can be fine at one cycling speed, but then fall off a cliff if you go too fast. Or temperature, some batteries are very sensitive to cold temperature, and the reliability really suffers. Where it sits in between use also matters. The state of charge during idle times can impact the degradation. So iPhones and laptops and things like that, when they ship out of the factory, they sit on the boat for a couple of weeks and then sit in storage for a couple of weeks before they're put into use. So typically, a lithium ion battery that's in a consumer electronics device ships at about 40% charge. And that's because when it sits at 40%, it degrades the least. If it sits at 0 or if it sits at 100% fully charged, the degradation of that battery will actually be greater at the end of the day if you receive it. So little things like that matter. The warranties are typically not just based on calendar time, although calendar time also causes degradation. They're often based on calendar time and number of cycles or throughput, so how the battery is being used. Unfortunately, similar to solar panels, oftentimes you kind of don't know if your battery is performing unless you go out and do a capacity test on the battery system. Some of the battery systems obviously have more electronics and functionality than a solar panel, which has none. And so you can do some capacity test. Maybe the battery can do a capacity test on itself, but it's probably something that needs to diagnostic that needs to be run. I don't think just a homeowner using a battery would know necessarily that their battery has degraded beyond the warrantable conditions.
Yeah. We all know that our cell phones, after we have them for 2 or 3 years or so, it's like, gee, it doesn't stay charged the whole day anymore. What happened? And, the battery's gotten a little low. I had experience with a hybrid car, and I had it over 100,000 miles. And I noticed at the beginning when I bought the car, boy, I could go around town and the engine would never start. And then after about 6 or 7 years, it was starting off. And then when the thing was like 10 years old, the engine had to start just to get out of the driveway. And the manufacturer, when I took it in, they said, oh, everything's fine. But they really know. So when we're here doing installations for commercial and residential customers who want storage, we're basically, I don't have the capability and the customer doesn't have the capability to kind of figure out what's going on a cell level. But we can trust big manufacturers that when they have a warranty, sometimes it's by 10 years or it's a certain number of megawatt hours over a period of time. That's kind of all we can trust. And we're also trusting them that they will let us know, or there's some way for us to determine the performance of the system as it degrades. Because with these residential and commercial batteries, they're basically being charged up every morning and discharged 70% or so every day. We keep 30% for backup use, but they're being beat on for 10 years. And the ones we've installed so far, they're just operating like champs. Good manufacturers, and we're happy. But I don't trust some of the newer entrants as much because they just don't have as much to lose.
Yeah, I think track record matters, and good experience with the battery system, especially over a couple of years, is pretty important. The technology is evolving fast, so history is not always a good guide for the future. Maybe their last year's product was high performer and some tweak in the manufacturing process or some optimization has an impact on the ability, but a track record does matter a lot, both for solar panels and for batteries. What we see is typically if a company has pretty solid process around product development and internal qualification and testing, that permeates through time.
Yeah. I've seen exactly the same thing, is that a lot of times the first year of a product or so are really good, and then they're looking at ways of cost reducing it, and they might have picked a component that wasn't as good, or their process had a hole in it, and then it kind of went downhill. And then from my perspective as a contractor, I just trust the bigger companies because their brand is important and they're not going to want to get a black eye. So we talked about batteries, we talked about solar panels. Have you done testing on inverters and racking systems and other BOS components?
Yeah, and on inverters, we actually also have the same product qualification program available. So we do a lot of inverter testing. We do a lot of qualification of inverters for the large residential installers, and welcome the smaller residential installers to participate in our program. It's free, as I mentioned earlier. The inverters, similar to batteries, do have some technology risk, and there's a huge range of performance. A lot of times with inverters, it's not just reliability that matters. It's actually the functionality of the inverter and the performance of the inverters. We had one of our clients do an analysis on a fleet of residential systems and try to correlate the yield of the system to variable. So to the inverter, to the module, to the installer, to whatever. And they said the biggest signal they saw was the inverter brand. And I thought, well, that's pretty obvious because of the inverter's downtime. And they said, no, actually subtracting the downtime, so availability adjusted, they still saw the inverter as the biggest culprit for reduced yield. And I thought this was interesting, slightly counterintuitive, because a lot of people think about an inverter as either on or off. It's just binary. If it's working, it's working. And if it's not, it's not. But in the reality is an inverter is tasked with a lot of functionality. And when it gets hot, it derates and will reduce its own operating output. Sometimes the maximum power point tracking algorithms aren't that good, especially on a residential system where it's partially soiled, where there's clouds or tree shading. It will not follow the maximum power point properly, or other various things that actually just reduce the performance of an inverter. So this is all stuff we can test in the lab, and we do test. And actually later this year, we have the second edition of our PV inverter scorecard coming out. So we released the first one last year and are excited to be releasing the second edition probably in a few months here.
You know, it's interesting that you're looking at the specific data. You're getting very granular. I'm kind of on the sharp end of the stick, supporting, thousands and thousands of systems out there. And without a doubt, and this goes back to 2001, without a doubt, the most common cause of customer concerns, service calls, has been the monitoring of the system. And usually it's not really the inverter's fault. It's something to do with the telecommunications. It's the router fails, they put in a new cable provider, they move a cord around the house and things aren't getting monitored properly. It's maddening, and it's a very hard thing to fix because we think that's going to work for a long time, but then people understand it. It's just unfortunate. And what I found is the best way to avoid those telecom problems, communication problems, is just to put in a cellular modem. And then the little SIM card goes in the inverter, and I don't have to worry about it for 5 years until they have to reinstate that card or buy a new card. Now, as far as looking at your experience over the years, any guidelines for businesses and homeowners who are putting in rooftop solar to figure out how to determine what's the most reliable equipment or vendors? I'm not asking for any particular names, but what would be your advice?
So the available information out there are scorecard reports, or as I mentioned, free downloads. You can go to pvel.com and just download the PV module reliability scorecard, PV inverter scorecard, and look for the brands that perform well in the testing. Unfortunately, beyond that, there's not much consumer reports style information out there for solar panels or solar inverters. As you said, going off your historical experience on going with vendors that have a track record of good performance, and then looking at the scorecard reports for the new products coming out.
Yeah, the scorecard reports are really useful. I mean, I haven't used them for inverters yet, but I've used them for modules. All right, let's change gears a little bit. How has the coronavirus affected the PV industry from your perspective?
Yeah, it's interesting. It's obviously affected everything in the world. I'm currently sitting at home here in San Francisco because I can't go into the office. This is month 4, month 5, something like that. So, and with no end in sight, I think everyone's getting pretty used to working from home. Initially, I think in March, April, a lot of the folks in the solar industry really thought the sky was falling and that solar was going to get a pause for many months. I think that because solar was deemed an essential industry, a lot of the work has continued, and come May, June, talking to a lot of developers, there's actually a lot more work continuing than I feared initially. So that's good news. There was probably a small dip in install rates, especially acute on the rooftop space, residential probably the most, commercial probably pretty bad, utility scale has for the most part continued with some potential delays, but nevertheless continued. There's only one utility scale project that I know of that has gotten canceled due to investors pulling out. Only one data point. So for the most part, I think most of the installation guidance from the market research firms has rebounded. So the expected total installs this year, 2020 in the U.S., probably down a bit from pre-coronavirus forecasts, but not down as bad as everybody feared initially. I think another really interesting implication is on module pricing. So module pricing, of course, is a function of the costs to manufacture it, and then the market dynamics, which will influence what premiums they can command. On the cost side, we are well in a global recession, which has implications on oil prices and commodities, glass and metal, all of which are raw materials into solar panels. And I think the cost of goods to manufacture a solar panel has dropped due to coronavirus pretty materially. So the actual costs to manufacture a solar panel are lower than pre-coronavirus times. I think the price drop is further exacerbated by, in the U.S., the tax policy has driven developers to stockpile panels over the past 3-4 quarters. And so there has been very high importation rates. So the megawatts brought into the ports have been high. At January 1st of this year, there was something like 11 gigawatts sitting in warehouses.
Wow.
Not being used. Yeah. And for the safe harbor policy of the ITC, the investment tax credit. So a slight reduction of installations with such high imports in the preceding few quarters means that Q2, Q3, Q4 of this year will have very low importation, most likely, which will further compress module prices. So I think the combination of the demand dropping and the cost of goods dropping will cause solar panel prices to fall pretty strongly from mid-year onward throughout 2020.
Yeah, we're seeing a real gradual decline. And ever since I started buying solar panels, every time you ask a manufacturer, they always say, "Oh, we're almost sold out. You better get your order in soon." But then, you know what's going on from a macroeconomic standpoint, that there's an excess of supply. So pricing is creeping down. It kind of reminds me of gasoline prices. They seem to go down really, really slowly, but then they jump up fast. Right. So we're seeing a gradual decline, and I don't see any reason why that's going to change until later in the year, and maybe later this year. There'll be some tightness in the market again as people kind of rush to put in systems to get the 26% tax credit. So it's a dynamic world we're in.
It's more dynamic now than it ever has been, probably, and exacerbated by irrational tax policy. I do think that the medium and long-term implications for solar from coronavirus are positive. So I think that a lot of the reinvestment plans that governments are putting together prioritize solar build-out or sustainability in some way. European Green Deal has put a lot of funding towards solar and just general green initiatives. I think probably something similar will happen in the U.S., of course, depending on what happens in November. But solar is going to be a central part of the recovery plans for governments around the world.
Yeah. It's just getting less and less expensive, more and more cost effective. Batteries are kind of getting out there, and they're very useful in a lot of different ways. So long-term, great future for the industry, and obviously a long-term great future for doing the kind of analysis that you guys do at PV Evolution Labs. How can people get in touch with PV Evolution Labs? So people can feel free to reach out to me on LinkedIn. I'm probably one of few Genyas in the solar industry, so just look me up, Jenya. Feel free to contact us through our website, pvel.com. We'll be as responsive as we can be. We have people reaching out to us pretty often, and our role in the industry is to support the installers. And so please don't hesitate to reach out to either me personally or to us through the website. All right. Well, that's great. That's all the time we have on this week's Energy Show. And thanks, Genya, for joining us. And thanks to all of our listeners for tuning in. If you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.